So in this video we are going to see one special case of LPP, that is nothing but infeasible solution. So let's directly start solving the example and then you will come to know what is this exactly. So the question given is minimize this objective function and then these two constraints and then this is non-negative constraint. Okay, so let's start solving with graphical method as we always do. So what is the first step? Let's take the first constraint, remove the inequality sign and just keep the equality sign. So that is what? X1 plus 2x2 equals to 4. I am removing this less than sign and just keeping this equal to sign. Now let's divide this complete equation with 4 so that I have 1 on the right hand side. Yes, that's how we do it, right? This is equation 1. So after division we get x1 by 4 plus this 2x2 by 4 means x2 by 2 equals to 1. This straightway gives you the coordinates A and B or the two coordinates, whatever you name it, no problem. So what are the coordinates? When it is below x1, that is going to be your x coordinate, so that is 4, and in that case y is 0. And whatever is below x2, that is going to be your y coordinate or x2 coordinate, that is what? 2. So in that case x1 is 0 or x coordinate is 0. Easy. This is the shortcut way of finding out, right? The traditional way is how? Like you put x1 as 0, find out x2, then you put x2 as 0 and find out x1. That way also you can find out the two coordinates. Whichever way you find easy, do it that way. This is just the shortcut trick to save your time in the exam. Now let's take the second equation. X1 plus x2. Remove this greater than sign, just keep this equal to 5. This is your equation number 2. Again do the same step, divide by 5 to this complete equation so that you have 1 on the right hand side. But with this trick you are not even allowed to have the minus 1 on the right hand side, right? So you should have 1 on the right hand side always. So if this is minus something, then you have to divide with minus so that this minus gets cancelled, okay? Right now it is simple. Divide by 5, so you get x1 by 5 plus this x2 by 5 equals to 1, and this will give you the next two coordinates C and D. Okay, so whatever is below x1, that is your x coordinate, y is 0. Here this is 5, 0. Only two equations, only two constraints were there, we got the 4 points accordingly. Now let's plot these points on the graph paper. For that, take a look at the coordinates first. So maximum value you see is 5, right? So I can have it with the gap of 1, 1 or 0.5, whatever you feel good. So 1 is also good. 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Yes. Let's plot the point. Point A is what? 4, 0. 4 on the x-axis, y on the 0 on the y. So this is A. Now next is what? B. B is what? 0, 2. So 0, 2 is this. Correct? This is B. Let's join these 2 points to form a line number 1. So these are the 2 points. This is my line 1. Yeah. Next is what? Point C and D. 5, 5. So this is 5 here. This is 5 here. So 5 on x-axis is your C and 5 on y-axis is your D. Yes. Let's join these 2 points again and that is your equation number 2 or line number 2. Okay. Easy up to this. Now we have to find out the feasible region, correct? We have to find out the closed polygon which covers the common lines for both the lines, both the equation. So let's find out the feasible region. For that, take a look at these inequality signs. So for first equation, it is what? Less than or equal to. So whenever it is less than or equal to, it is towards origin, correct? So line number 1 is what? This line, correct? So this is basically coming towards origin. So this is origin, yes. So this is coming in this direction. Yes, this is towards origin. Line number 2 is what? Greater than or equal to, means this is going away from the origin. So this is your line number 2. So this is going away from the origin. Here is the origin, right? So this is definitely going away from the origin. Yes. So now, do you see any common region? And we are talking about first quadrant only. Always remember, LPP problems are solved in the first quadrant only. That does not mean that you are not going to get the negative coordinates at all. You may get the negative coordinates. That is fine. That is valid. But then the feasible region which you are going to seek is in the first quadrant only. Yes. So in the first quadrant, do you see any common region right now? No. Both the lines are moving in the opposite direction basically. Yes. This is moving upward, this is moving downwards. So this LPP does not have a common region basically, and that is nothing but the infeasible solution. You getting my point? Because you don't have any feasible region, and that is the reason this is the infeasible solution. So how do you conclude such examples? Simply you can write down like the two lines don't have any common region or any feasible region in common, and that is why this solution is infeasible solution. Clear? Easy? Very easy, but students just get confused because they see something like this and they are just used to the common examples or the usual examples. So I just wanted to show such different or different scenarios from LPP, right? Those are also asked in the exam to confuse the students. Otherwise these are very easy, right? You don't have to do anything further because you don't have common region itself. So you should know in this case, this is also a valid scenario in LPP problem. This is known as infeasible solution. So if you like this video, please like, share and subscribe to my channel. See you in the next video. Bye.